Right. So as I mentioned, cracks, honeycombs, backhoes, scaling, spalling, pop-outs, dusting, interrogation, discoloring are all defects that may happen to the concrete, but they all have degrees of impact on the concrete. For instance, if it's just discoloration, it might not be a structural issue, but when you end up having like shrinkage cracks, you have plastic settlement, we have cracks, then that becomes a structural issue because these cracks allow the ingress of external factors such as carbonation or chloride attacking the reinforcement, and that can cause a damage to the structure. So these are defects that may happen. And one major thing is if these defects are not prevented or they are not solved at the early stage, then the cost of repair becomes very expensive because deterioration keeps happening once you have the exposures continued for a longer period of time. Now we move to the common defects. Now, a research has shown that most of the defects we have on our site or in our project site, approximately 36% are related to construction and supervision problems. And we have about 26% being design problems, 21% being an issue of exposure conditions like the temperature, the wind, and all those kind of stuff. Then the other aspect is the choice of material, the quality of material that is used for the project. So as you can see, construction and supervision forms a greater part of the defects we mostly have on our project site. So that means that if you have artisans or you have people on site who are not supervising their works well, definitely you end up have issues. Like the form work for concreting, if the form works are not properly done, if you are casting concrete and it's not properly vibrated or there's another vibration, the mixed designs are not properly mixed on site, you end up having so much water, there's bleeding in the concrete. All these things are defects that will result in other things when you allow this to happen on site. So the human resource on site and their capabilities and their technical capabilities are key to construction, whether you want to achieve a good concrete or you have some defects on the site. So this is a summary of a research that was conducted about 1997. And this is true from the experience you had. Most of the issues you meet on site are mostly related to the supervision problems on site. Now we move to the first, discoloration. Discoloration mostly happens on site. I know some of us have seen such issues before. One of the major causes of discoloration are the changes in our cement quality. Some of the cements have different colors. So if let's say you want one particular finish of concrete and you use different cement, definitely you may end up having some different colors at certain sections because of the source of clinkers are different. Another aspect is when you are constructing, then you add so much water to the concrete. At the plastic stage, when the concrete is drying, you have water on the surface. When the concrete is drying, there will be moisture loss. The moisture loss will leave a lot of cement latents on the surfaces. And some of the concrete, when we are finishing like the tool finish, and you finish on such a latent, you end up having some patches on the surface. You can see the picture on the screen, which has some black spots. All these are patches on the concrete when we are finishing it. Sometimes also we end up using cement replacements because you want to control maybe heat of hydration in the cement. You want to do some replacement. You end up adding sometimes pozzolans, sometimes GGBS, sometimes silica fumes. You add some replacements. All these cement replacement can cause some discoloration if not properly mixed and uniformly distributed within the concrete. They can lead to some patches on the concrete surfaces. Some concrete you may add up some calcium chloride to the concrete. And you know, chloride, these are salt, and when they evaporate, this salt deposit will leave on the surfaces. Once the moisture leaves the concrete, then you have some whitish patches on the concrete surfaces. Overdose of retardants. Concrete admixtures are very relevant in our construction, but sometimes if you don't know how to dose it, it's not properly designed for, and you overuse it, you end up having such defects on the concrete surfaces. Poor workmanship, as I mentioned in the previous slide, most of the defects on site are related to workmanship and supervision. So poor workmanship, sometimes if you are finishing concrete like a floor slab, the casting of concrete, finishing the floor slab, then you see the masons putting a lot of water on the surface and be floating and be rubbing it. At the end of the day, you end up having some patches on the surfaces. And sometimes they overwork the surfaces. They can float the surface for long hours, and that can also cause some discoloring on the surface, some damp patches. You can see some dark spots also on the surfaces. And uneven curing. When you don't cure the concrete evenly, you cure some parts, you leave the other parts. The part which is undergoing curing will take its time and dry properly. The other side, which is not being cured properly, will dry faster and will have some whitish patches on the surfaces. So curing also has to be uniform. If you are using curing compound, it has to be uniformly sprayed. If you are using water, you always have to make sure that the water is always sprayed on the entire surface. If you are using damp materials like sacks or geotextile membranes, you also have to make sure that you cover the entire surface and always soak with water to allow for proper curing. Okay. Now, how do you prevent discoloring? One of the major issues is to prevent the use of calcium chloride. If you don't have knowledge in the use or how to incorporate it in the mix design, you just desist from using it because it has to be properly controlled in the mix design. Also, when you are using formwork and you have absorbent formworks, so most of the wood formworks we have, no, I'm not talking about the laminated ones, the normal ones, after casting the concrete, you could see that it has a different look because the formwork stains the concrete. So if you want a very good concrete, reinforcement is the formwork is very important. The kind of formwork you use is very important. So you need to prevent the use of the absorbent reinforcement so that it doesn't stain the concrete. Also, when you are casting concrete, you also have to make sure that the mold release agent you use are very compatible. Sometimes we end up using dirty oil on most of our project sites, and by the time you take out the form where you can see that black spot on the surfaces, you have to use proper mold release agent for such works. And also do not over apply it. Even though you have to use it, do not over apply it. If you have so much of it on the formwork, it pons at a section of the slab or in the formwork. So once you cast the concrete and dries, by the time you take the formwork, because that place is ponded, it has so much of the mold release agent and that stains the concrete. So you need to moderately apply it. You have to know how to apply it based on the consumptions, that you can apply it properly. Also, proper curing is very recommended. It's recommended that you do proper curing for all your concrete works to ensure that the drying processes is for the concrete is uniform on all the areas so that you don't have any patches or isolated dryings on some sections of the concrete. Now, how do you repair such defects? For discoloring of surfaces, the main way you can repair such things is by cleansing. If you have colors on the surface, you can cleanse the surface and wash it. You can also do acid wash. If you want to maintain a color, you can do what we call the tinting. You can tint the concrete or you apply a cosmetic material. Now, cosmetic materials are materials specially designed to allow the concrete to look similar. So if you have a concrete that has patches on the surface, you can apply some cosmetic fillers on the surface to remove all the damp patches and to offer a uniform look to the entire concrete. So these are examples you can do to repair such defects. Other aspects are also by special coating. If you have a floor that has this kind of patches, you can go in for resin coating or a pigmented coating that can offer a very good finishing as well. So these are options you can adapt to repair discoloring on concrete surfaces. Now, when it comes to cracks, there are different kinds of cracks. And the cracks can be grouped into two. We have the non-structural and the structural cracks. Non-structural cracks are cracks that do not affect the serviceability of the structure. So it's more of aesthetic. So the cracks are there. It's not affecting the performance, the structural performance of the structure. However, it is not pleasing to look at. So those are the non-structural cracks. Structural cracks are the cracks that has an effect on the structural performance, where we call the serviceability of the structure. So these are the two different cracks. Now we have the plastic shrinkage. We look at what is plastic shrinkage crack is. We also look at the plastic settlement. When you say plastic settlement crack, what does it mean? Thermal cracks, we look at what it means. And when it comes to settlement cracks, we also look at what this means. Now, when it comes to plastic shrinkage Plastic shrinkage is when you cast concrete, what happens is you have the surface covered with water or a film of water. Now, this film of water will definitely leave the surface, but the rate at which this water leaves the surface, that surface water has to be recharged by the water in the concrete itself. So, as the water is leaving the surface, another water from the concrete must also come to the surface to recharge it. But sometimes you have this loss of moisture or loss of water on the surface rapid than the rate of recharge from the water from the concrete itself. So that creates the differential between the surface and the concrete itself. Now, when this happens, because there's loss of water on the surface are very high, the drying process on the surface becomes very high, faster. So when it dries faster, the surface becomes hard. So the time the rest of the concrete begins to set and shrink a little, then it causes a pull on the surface that causes some cracks. So this kind of shrinkage cracks, plastic shrinkage cracks, are mostly seen within the first 1 to 6 hours of the application of the concrete. When you apply the concrete, within first 6 hours, 1 to 6 hours, you have these defects happening. And as I mentioned, the major cause of it is the high evaporation rates of the water from the surface. So when the water leaves the surface and there's no recharge, the water does not recharge in the surface, definitely you have what you call the plastic shrinkages. Now you can see a typical example of how the plastic shrinkage looks like. So you can see that they are all they are straight in a certain pattern, but they are not connected. So once you see a defect like this, then that gives you an indication that it's a plastic shrinkage crack. Now, the environmental conditions that affect this, that causes this kind of cracks are the ambient temperature. When you have a higher temperature, because higher temperatures will definitely result in a higher loss of moisture. And when the concrete temperature is so high, when this concrete is hot, also you have a lot of moisture leaving the concrete. When you have low humidity, especially if you are casting concrete in the drying season, you see that the humidity is very, very low. In that sense, the loss of water from the surface of concrete will be higher than the rate of recharge. In that sense, that differential will cause the plastic shrinkage on the surfaces and the subsequent cracking. Also, when you have high wind, okay, when you are constructing and it's exposed and you have the wind speed more than 5 miles per hour, definitely you have this kind of issues because the moisture loss on the surface will be higher than the rate of recharge of water from the concrete itself. How do you minimize such defects if you are constructing and you can see all these things are prone to your concrete? How do you minimize these effects? First and foremost, when you are casting the concrete on a subgrade, okay, it has to be made damp. So let's give a typical example. You are casting an oversized concrete on the backfill material. Now, when you cast this concrete or oversized concrete on this backfill material, because the backfill material is dry, it will absorb moisture from the concrete faster. So the amount of water needed by the concrete to even recharge the surfaces will not be present. In that sense, you have a lot of shrinkage in the surfaces. So the use of DPM on materials, subgrade materials, are very key. If you don't want to use such material, then you have to make sure that you pre-wet the subgrade. You have to water the floor to make sure that it doesn't have any affinity for water before you put the concrete on it. In that sense, you are sure that you will not have faster moisture loss from the concrete. Then you can have the moisture in the concrete recharging the surface to prevent these shrinkages. Also, you can also prevent this by preventing the excess water loss by the use of curing compounds. You can go for the spraying material where you put on the surface, then it seals the surface from losing moisture. Or you can recharge the surface by the spraying of water, which is a normal curing you mostly do. You put water on the surface. In some cases, you spread some juice on the surfaces where you put water so that it retains the water for a period of time. And some of the projects also on slabs, they mostly use sand. Then you put water on it. All of these are ways you can cure. The essence of this is to prevent the faster moisture loss on the surfaces. And once you do that, that will prevent the shrinkage on the surfaces. And one key thing you can also do to regulate or control this is the addition of fibers, synthetic fibers. when you have fibers in your concrete and it's undergoing shrinkage, because these are reinforced materials, they end up helping in the prevention of the shrinkage cracks on the surfaces. And one key thing you must go with is to make sure that you cure properly, and you must know the time to start the curing. The moment the concrete starts moving from the plastic to the solid state, you have to start curing. When you know that you can step on the concrete with your foot without having your foot entering the concrete, that's the time you need to start the concrete. So once you cast concrete, you need to monitor it. At that transition stage, you need to start your curing, else you end up having a lot of shrinkage cracks on the surfaces, the plastic shrinkage cracks. How do you repair this kind of cracks? Sometimes you have to open the cracks, because some of these cracks are not deep cracks. They are just surface cracks. They are not deep cracks. So we can just open the surface by cutting into the V shape. Then you repair with cementitious materials, which have the same strength as the existing concrete. In some cases, you can use resin materials. You can use an epoxy material. You mix the epoxy with sand, then you can use to seal the crack. All these are ways you can repair these cracks. And sometimes also when you have the cracks a lot on the surface, like the picture I showed, you may have to remove the cover on the surface and probably recast it. You have to remove the cover and recast the surface to restore that, because when you have reinforcement closer to the surface and you have such cracks on the surfaces, you exposure conditions like carbonations or chloride attacks are very, very common. So you have this water, dissolved salt will enter these cracks, then they have access to the reinforcement and they begin to react. Then corrosion sets in, the reinforcement begin to lose its potency. So these cracks, once you notice that these are a lot on the surface, you can just remove the surface concrete, take off all the cracks, and you can replace it with the concrete or a structural repair mortar to restore the integrity of the structure. Another kind of crack that we mostly see are the plastic settlement. Now, plastic settlement, one key thing you can use to identify plastic settlement is they are always in the direction of the reinforcement. So how does this happen? When you have concrete, okay, and the concrete is moving from the liquid to the solid state, it undergoes self-compaction. Now, when it's undergoing self-compaction and the concrete is rearranging itself, sometimes the reinforcement serves as a blockage to the downward movement of the concrete. So you can see that the concrete will sit, but right under the reinforcement, there will not be any concrete at that section. Then you can see that the top of it will begin to crack because of tension, introduction of tension on the surfaces. So you can see from this, you can see the illustration, the reinforcement from a fresh concrete. When the concrete is settling, you can see that the aggregate is moving down. That is where the concrete is undergoing self-compaction. Now, because you have the reinforcement in position, the aggregates will be stopped or be blocked by the reinforcement. So the compaction, you have only slurries going underneath the reinforcement. And over time, this slurries or the water that goes under reinforcement will dry out. Then you have this cracks happening. So you can see on the surfaces, this is a typical example. We can see that the rebar positions, you can see there are cracks along the rebar position, reinforcement position. So these are plastic settlement. And it mostly happens when you have heavy reinforcement and you don't properly compact it with by vibration. And also when you end up having so much water in your concrete, then the concrete will begin to sit on its own, to compact on its own. Then the reinforcement will serve as blockades to the aggregates. Then you have the shrinkages happening. In the event where the reinforcement are closer to the surfaces, the concrete cover is subjected to tensile stresses that causes cracks. So that is when you see that the cracks are along the reinforcement. So that is the major cause of for plastic settlement. Now, as you can see, reinforcement bars, the concrete hangs up, then the top layer of the rebar, while the surrounding concrete continue to sink, creating a tier directly above it. Sometimes also the compaction that is done on the fill material is also not adequate. So once you put the concrete, especially when you have a very thick concrete and the weight is heavy on the base material, then it compacts the earth. Once the earth is compacting, then that causes a downward movement of the concrete. All these things can lead to cracks on the surfaces. So how do you repair such cracks? Now, for such cracks, one of the ways you can solve that is by means of injection. Simply because if you have a crack that is under a reinforcement, it's very difficult to go behind the reinforcement only and repair it. So what you can do is you can drill to intercept those cracks and inject a resin material that can seal all the crack. So use a low viscosity material. Why low viscosity? Some of the cracks are very tiny, and that if you have a high viscosity material, getting it through the crack is nearly impossible unless a high pressure. But because the surface of the crack is open, high pressure may be causing the resin material to seep out. So you need a low viscosity material to be able to seep through all the cracks. In some cases, you can do gravity injection by just pouring the material into the crack, and that will fill the crack. So that's another option. So for depending on the depth of it, then you can go for the injection or you can go for the gravity injection by just pouring the water, the resin on the surface to seep through the crack. So these are options that you can adapt. Now, in the event where you can remove the concrete and redo on the surface, it's also advisable. You can also do that to repair the concrete. The reason you need to do this is the concrete cover serves as a protection for the reinforcement. So once this is compromised or there are cracks in it, then you're allowing the reinforcement to be exposed to external conditions that may affect the durability of the reinforcement. So that needs to be protected. Another aspect is thermal cracks. Now, thermal cracks, there are two types of thermal cracks that I want to talk about. We have one that happens during the hardening process of concrete, and we have another thermal impact that happens after the concrete is hardened. Now, thermal cracks mostly happens when you have differential temperatures. So we all know that cement when it's undergoing hydration process, there is definitely heat generation. Now, this heat generation causes an expansion of the concrete mass. However, when you have the ambient temperature lower, then that differential temperature will cause a lot of cracks because the surface or the exterior of the concrete will be cold, and that will be undergoing shrinkages, while the inner part of the concrete will be hot and be undergoing expansion. So that pull of the inner core on the hardened surface, which is cold, will cause that crack. That differential temperature will cause that crack on the surfaces. So that pull and the push between the surface and the core of the concrete, that's what leads to the thermal cracks on the surfaces during the setting period of the concrete. So as I explained, the surface of the concrete could be exposed to a lower temperature, whilst the inner core of the concrete will be undergoing a lot of heat because of the heat of hydration. The core will begin to expand because you know that every material, when it's exposed to heat, it undergoes expansion. Then the expansion will cause the pull on the surface, which is already cold. Then that will cause some cracks on the surfaces. Now, this illustration gives an idea of what we mean when we say the inner core of the concrete becomes very hot. So when you have a thicker concrete mass, like you are casting rafts, okay, 0.6 thickness, 1 meter thickness, 1.5 thickness, when you cast such concrete, the inner core becomes very, very hot. Very, very hot. You can see the red indicates the inner core of the concrete. It becomes very hot with a lot of heat. And when you have a lot of wind on the outside or the ambient temperature is very cold, then you end up having the surface also cold. Now, most of the time, people we think that casting concrete in the night is good. Yes, it is. It's good. But casting concrete in the night and not putting necessary measures to cool the inner core can also cause some cracks on the concrete surface because in the night, the ambient temperature is lower, but the concrete core could have a lot of heat. And this differential heat may end up causing some cracks on the surfaces. So you should know how to be able to balance the inner core heat and also how to reduce the steepness of the temperature gradient between the inner core and the outer concrete. So how do you minimize this kind of cracks? So these thermal cracks can be reduced by controlling the heat of hydration. Now, cement, when it reacts with water, it undergoes what you call the heat of hydration. That's when the solidification process begins. And this process ends up generating a lot of heat. So if you want to reduce the heat, then what you can do is also to put in some what you call some cement replacement materials, that the pozzolans, fly ash, GGBS. This can also be introduced in the concrete. Now, when you do this cement replacement, meaning you are reducing the quantity of cement in the concrete. In that sense, you are reducing the amount of heat that could be generated. So introducing these materials, pozzolans in the concrete, fly ash in the concrete, can also help reduce that. Secondly, in some cases, you may even have to use cold water for the concrete. And that can also regulate the inner core temperature of the concrete. You can sometimes use the concrete. In some cases, in Dubai, for instance, most of the constructions, they install pipes in the concrete where they run cold water through the pipes. So as they cast the concrete, there are pipes that are installed in the concrete. Then as the concrete is hardening, they run cold water through the pipes. And that helps control the temperature of the concrete. And also, in terms of pouring, you have to plan the pouring process and know the volume that you need to cast at a time, and also to be able to control it. If you don't plan the pouring process and you go around and just cast huge volumes, you may end up having a lot of cracks. I'm not saying casting huge volumes are not advisable. You can do that, but you also have to make sure that you put in the necessary measures to make sure that the heat is controlled, so that you can reduce the possible cracks that may happen in the concrete. Sometimes also you have to install what they call expansion joints to allow for set things, so that you have the concrete being poured in blocks, separate units that are going to serve as different blocks, so that if there's supposed to be expansion and contraction by the inner core heat, then that is regulated within a specific space. It doesn't translate to a bigger area that can cause a lot of cracks. So that can also be regulated by the introduction of expansion joints in the concrete. So that talks about the thermal crack when the concrete is moving from the plastic to the solid state. Now, another form of the thermal crack is when the concrete has already undergone the setting. It has already set. It's been there for a longer time, but it's exposed to heat. It's also another form of thermal crack that may happen to the concrete. And these are because of the cyclic heating and the cooling of the concrete. So we all know that concrete is very weak in tension and strong in compression. Now, when you have a concrete exposed to a lot of heat, it will definitely expand. Now, when it expands and the evening time is cooling, it has to coil back. Now, the process of coiling back, the concrete will be in tension because it's trying to pull the units from each other to come back to the original state. Then that presents the concrete under tension. So this tensile stresses in the concrete ends up causing a lot of cracks. That's why we sometimes advise that you can use the PP fibers or synthetic fibers in the concrete, so that it allows such movement without the cause of cracks in the concrete mass. How do you repair such cracks? Now, thermal cracks could be deep cracks because of the heat generated. So best option to repair thermal cracks are the injections, because if you're injecting, you have to inject and make sure that the whole crack is injected. How do you know you've injected the whole crack? Before you do the crack injection, you can do the UPV test to understand the depth of the crack. Once you establish the depth of the crack, you know where to intercept the cracks before you go on with the injection material. If these cracks are not deep, these are just superficial cracks on the surface, then you can do a V cut on the surface. You open the crack wider on the surface, then you can seal it with some resin materials or a structural repair mortar to patch the surfaces to seal them. The objective of this is to improve durability. Some of these cracks may not affect the structural performance of the element. Has a durability concern because you end up having water seeping through that, and this water may carry dissolved salt that will affect the reinforcement. In the presence of sulfate, that will definitely affect the concrete, the cement paste in the concrete. In the presence of chloride, that will also attack the reinforcement. So it's very necessary that once you have cracks in your structure, in the concrete, wherever you have your cracks, you make sure that you do an injection or properly seal the crack to prevent all these exposure conditions from affecting your structure. Now, this is a video of how the injection process right, so that summarizes the injection process for the repair of deep cracks. Now, when you have a crack and it's a dynamic crack, these are cracks where after repair, there's a possibility of the cracks happening again. We call it dynamic cracks. So meaning no matter what you do, the cracks keep opening. Such cracks, when you do the rigid sealing or you do a kind of injection with a rigid material, the possibility of the crack happening again is very high. So how do you prevent that? We can also go on by what you call the stitching. So the stitching of this crack you can do with the carbon fiber. So you cut across the crack, then you insert a carbon fiber material into the crack with an adhesive. So that restrains the concrete from moving along that plane. So that can be done to stitch it. In some cases, if the crack is not a serviceability concern, but just a durability concern, you can do a flexible injection. Flexible injection means that you are sealing the crack with a material that is flexible. That material will not allow water to ingress. So it means it has a durability property. It can protect your structure or the concrete or the reinforcement from the impact of chlorides or sulfate attacks. So that can also be done. But where the crack is dynamic and you want to prevent the movement and the reoccurrence of the crack, then in addition to the crack injection, you may have to stitch the crack as well with the carbon fiber across the crack so that that restrains and prevents the further movement and the development of that crack after the stitching. So that can also be done to prevent future occurrences. Now, dusting is sometimes when you cast the concrete and it dries and you pass your hand on the surface, you see that you have a lot of dust coming from the surfaces. The main cause of this is sometimes you have less cement in your mix design. That's one of them. Secondly, you may also end up having a lot of slurries. So when you have so much water in your concrete and it dries, it pushes a lot of slurries to the surface, which is cement paste without aggregates. So when you have this cement paste on the surfaces, which is called the cement latex, all those ones end up rendering the surfaces very dusty. So you can see that when you pass your hand on it, then it begins to form dust. And for industrial floors where you have a lot of forklift, plying set floors, you could see that then the floor is always dusting. And to get to a time where you can see that the aggregates are also being exposed, simply because the paste material or the fine particles, which is the cement plus the sand, are being worn out by under the mechanical load. So once you have less cement in your concrete, which is the binding element, you have this kind of issues. Once you have so much water in your concrete, also you end up having a lot of dusting on the surface. Then, as I mentioned, when you have low cement content in your concrete, you end up having some dust on the surface because the binding element to be less. You have a lot of dust or a lot of fine materials on the surfaces. Adding excessive water and also placing non-absorbent subgrade or polyethylene vapor. So when you are using DPM and you have so much water in your concrete, definitely you have a lot of slurries coming on the surface because the subgrade will not be absorbing any moisture from it. So you should know what you are offering and know the kind of mix design you need to do. So when you have so much water, slurries come on the surface, the drying process will end up leaving some cement residue on the surface. You have that dusting on the surface. And sometimes also when you have rapid drying, when the surface undergoes rapid drying, hydration takes time. When it dries faster and there's no available moisture to allow for continual hydration of the cement particles, definitely you have dust on the surface because you have a lot of you have a lot of unhydrated cement on the surfaces. And cement has to be hydrated to be able to offer that matrix to bond the surfaces. But once you have the cement unhydrated, then you have this kind of dust on the surface because you have there was a faster drying and there was not enough water to allow the cement to undergo hydration. So that can cause a lot of dust on the surface. How do you prevent that? One, you need to do proper curing so that there's no faster drying on the surfaces. And also need to take note of the weather conditions. If the weather is hot, you also have to know when you go ahead with your concrete casting and to be sure that it doesn't have any effect on the surfaces. Now, how do you prevent that? Okay, once you do set a concrete, you can always introduce what we call a surface hardener to the concrete to serve as an additional protection, also as additional strength on the surface. So as the concrete is still fresh in the plastic stage, you strew in the surface hardener on the surface, then you can float it, whether manual floating or power floating, so that you can achieve that hardness on the surface. With that hardness, you are sure that there's no going to be any dusting under loading, forklift and vehicular loading. You are sure that that's going to be taken care of. Another aspect, another way is to introduce what they call the resin coating. So once you have the surface dusting, you can prepare the surface very well, introduce a resin coating, that's a pigmented coating that can also serve as an anti-dust and also gives out a very good finishing. Sometimes also too, you can do a self-leveling screed on the surface to, after power washing the surface, you do a self-leveling material that has a good strength like the concrete, existing concrete on the entire surface to give the same performance. So these are options that are available. You can recast a self-leveling material as low as even 10 mm thickness or 12 mm thickness can be done on the entire surfaces. Where you want to do a pigmented coating, you can go on with the epoxy finish or those kind of coatings to give it a very good finish. And so that's what you can do to repair a dusting surface. Now, reinforcement corrosion, as I mentioned, reinforced concrete is a composite material, and the performance of the concrete depends on the reinforcement, and the performance of the reinforcement also depends on the concrete. Because when you cast concrete in the first state, concrete is basic, the pH is around 13, 14, but some external factors like carbonation can cause the pH of the concrete to be lowered. Now, when this process happens, the concrete becomes acidic, and this acidity breaks down the protection around the reinforcement, and that's what causes the setting of corrosion caused by carbonation. So once you have reinforcement in concrete and it's undergoing corrosion, it undergoes a process called expansion because of the corrosion. Now this expansion will cause the concrete to start breaking off, as you can see in the picture. So these are typical examples of reinforcement corrosion. Okay, one is the carbonation process. Carbonation process is what I've explained. So carbon dioxide enters into the concrete with air. Then once there's a presence of moisture, then it becomes acidic. Then the pH of the concrete begins to drop from basic to acidity. Now, when this transition is happening, it breaks down the protection around the reinforcement, and that causes the setting of the corrosion. Now, there are chloride also attacks. Chloride attacks are mostly in areas where we have dissolved salt in water. So we have the salt passing through the concrete by the process of capillary action. Now, this chlorides attack the reinforcement and begins to eat them up. Then they reduce in sizes. So that's what affects the reinforcement. And now, once you have the reinforcement affected, the composite performance of the structure is so compromised because the reinforcement is taking care of the tensile stresses that are present in the concrete. So once you have the sizes reduced, the meaning that this is also going to be compromised. So this explains the processes of carbonation. So before the reinforcement is exposed to external factors, the exposure conditions, and once it starts, the acidity begins to drop, the reinforcement begins to expand. Now, when it expands, because concrete is weak in tension, the reinforcement expansion exerts a pressure on the concrete that begins to pull it off. Then we have the system what you call the spalling concrete. The concrete begins to spall, then it breaks off. So that's the process of how the spalling process happening. Now, this video gives an indication of how the process of the corrosion happens, right from the introduction of moisture to the expansion and the breaking of the concrete. All right, so that summarizes the corrosion process induced by carbonation. So from the introduction of moisture and the carbon dioxide causing the concrete to be acidic, then that breaks the protection of the reinforcement, then that causes the setting of the corrosion and expansion, then the concrete begins to fall off. So how do you prevent such things from happening? We need to make sure that the concrete is not permeable, or at least the permeability is as low as possible. And this can be achieved by doing a very good mix design with a low water cement ratio. But in doing so, the workability is compromised. That's when you need to introduce plasticizers to compensate for that. So with the low water cement ratio, you add plasticizers to get the workability and make sure that you have low water cement ratio. Then you have a very watertight concrete. You can also use other products like corrosion inhibitors. Corrosion inhibitors are materials you can add into your concrete and replace it. Once you have this done, then it means the pores are blocked, and this also serves as additional protection around the reinforcement. It forms the film around the reinforcement that does not allow access by the carbonated instances to affect the reinforcement. That can be done. Another aspect is also to increase the concrete cover. Once you have a very big concrete cover, a thicker concrete cover, and even it's exposed to carbonation, it takes a longer time for the acidity to reach where the reinforcement is. In that sense, the reinforcement stays protected for a longer time. So for exposure conditions like construction closer to the sea, or in an environment where there are a lot of dissolved salt in the ground, we always advise that the typical concrete cover should not be less than 40 mm. The higher you go, the better, because it will take a longer time for the reinforcement to be affected due to the thicker concrete cover. Another aspect is to protect the concrete. So we can also, after the concrete has dried or has set, you can also put some protection materials on the surface. We call it surface protection. Surface protection materials are materials that prevent the ingress or probably the external factors from entering the concrete to cause a change in the acidity of it. So once you have the surface protection, these things, some of them are waterproofing products, some of them are just special material that impregnates the surface of the concrete and makes it watertight. So once you have the external factors coming in, these materials don't end up affecting the reinforcement. Some of the repair processes for how do you repair such defects? The first and foremost, you need to make sure that you expose all the reinforcement. Once it has undergone corrosion, you make sure that you have to expose it, because if you don't expose and you do any surface repairs, the corrosion will continue and be expanding at other sections, and you end up having the defects from happening. So what you need to do is first expose the reinforcement. Now, once you've exposed the reinforcement, we need to check whether the sizes have reduced or it's still the same. If the sizes have reduced, then there has to be a replacement, because in design, you look at the area of reinforcement in a particular element, and once the sizes are reduced, meaning the areas are also compromised, so there has to be a replacement. And you have to make sure that you derust all the reinforcement and also protect it from further corroding. So you can see this steps summarizes the concrete repair processes. So first, you have to expose the reinforcement and make sure that you go behind it and make sure that the reinforcement is completely exposed. Then once you have done that exposure, you protect it from further corrosion by the application of corrosion protection material. Then you can go ahead and do the concrete replacement with either a concrete repair mortar, or probably you cast another concrete in place. Now, when you cast this concrete in place, you can also do a fine filler on the surface, or you do a surface protection that will prevent further ingress or further deterioration. Now, there's a video that summarizes the processes that I want to show all of us so that we can appreciate concrete repair process. Sorry, let me just go back to Okay, so in conclusion, we all understand that concrete has to be well casted, and to be able to cast it well, it needs proper workmanship, and also quality of materials and supervision. And also, we need to understand the environment under which you are going to cast the concrete, the temperature variations. We also need to have an idea that when you are casting thicker concrete, definitely there's going to be that heat variation between the surface and the core of the concrete that can lead to a lot of cracks. And some of the repair methods we mentioned are the injection methods with the PU materials. We can also do the stitching of cracks. We can do flexible ceilings. To prevent certain things from happening, also, you can go on with the protection materials where you end up protecting the concrete from these exposure conditions. At MC, we are available to assist in any of your inquiries. Whenever you have issues, you have said defects on your site, or you want to make any inquiries, we will always be available to support you. So at this point, I will give about 10 minutes for if we have any questions from this presentation, then we can all look at it together. Thank you. Okay, Matthew, you have your hand raised. You can go on.
Okay, good morning, everyone. Thank you for having me here. My question is, right now, I'm specifically talking about thermal cracks in concrete. Now we have reinforced bars which are plastic. Some call them plastic reinforced polymer. So
Yeah,
for plastics for thermal cracks, you are saying something about it's being heated beneath the concrete surface. Well,
yeah.
we have right now we have the plastic reinforced polymer. So I wanted to know whether if it get heated, will it burn the plastic reinforced polymer to the extent that it will be burning small, and to break in future or something like that?
Okay, so this is an interesting question. Now, if you look at the process of producing those polymers, the glass fiber reinforcement, okay, it
Yes, sir.
undergoes it's actually glass fiber plus resin, which undergoes it's always taken through hotter temperatures. Now, the kind of temperature I'm talking about within the concrete core is not something that can cause the burning, but it can cause an expansion of the concrete itself. So that is where the issue is. So when you talk of these thermal cracks are happening because the concrete is expanding because of excess heat. Now, when the concrete expands because of excess heat and it is now cooling, by the time it is cooling, the concrete has already started setting. So you have a lot of micro cracks already in the concrete because of that initial expansion. And once the concrete is setting, it's set at the expansion stage, not at the compacted stage. So that introduces a lot of micro cracks in the concrete, and that affects the durability of the structure. But on the surfaces, you have a lot of cracks happening on the surface. Those are the ones which are visible. But the depth of the concrete also has some cracks in it that will affect the strength. Are you okay? So for the heat from the concrete, I'm not too sure that that can affect the fiber reinforcement, because in the production process, it's resin and also some heat that's applied, which is higher than that of the heat that will be generated by the concrete.
Oh, okay, sir. Thank you.
And Edwin, do you have your hands up? Edwin. Okay, Joshua.
Hello, can I be heard?
Yes, I can hear you.
Okay, so one of the rumors I hear going around is that in pertaining to the cracks, that retarders can help reduce the risk of cracks. How true is this?
Okay. So when it comes to retarder just slows down a certain time the concrete. Okay. It's not entirely true, but sometimes it helps. But as I mentioned earlier, if let's say you have a concrete that you need to overwork the surface, like a floor slab, you want to you want to finish it well properly, and you are casting bigger areas, like a larger areas, like a warehouse for about, let's say, 10,000, 15,000, something like 2,000 square meters. If you don't use a retarder and you cast the concrete, by the time you come back to work on the surface, it's already dried. And that is when you end up putting a lot of water on the surface, because you want to get the surface workable to be able to work on. But when you have a retarder, it can give you that freedom to be able to cast large pores, okay, and allow you to be able to work on it smoothly without any defect. So in that sense, it can help. But retarders don't stop it delays the hydration process. It doesn't stop it. So if it delays for a period of time and the hydration starts, definitely the heat generation is going to be there. You understand?
Yeah.
Yes, the heat generation is going to be there once the hydration starts. Retarders just delay the hydration process, but it doesn't stop it. But the time the hydration process starts, definitely the heat of hydration is going to happen. So we need to put the measures to control that. It can only delay and make sure that you can have large pores and be able to work on it without having an issue. And also when you have hot temperatures, it can delay the setting so that you don't have much moisture loss on the side, because once the surface dries faster and the concrete sets, that's when you have these effects happening. But when you have this retarders and it's delaying the setting time, you have the freedom to be able to work on the surface very well. And it can also help you for the travel time of concrete. There's a question, or is there a question or a contribution?
Another one is like a threefold. I want to just play it really quick and then I mean,
Come again.
is it true also that higher grade concrete has lower risk of cracks?
It's not true, because higher grade concrete has a lot of cement. Because higher
Mhm.
grade concrete mostly have the cement content are high, so in terms of heat of hydration is high. Okay, so all what you've talked about is common with low grade concrete and higher grade concrete. The only thing with higher grade concrete is because higher grade concrete is denser. In that sense, you have less pores. So when it comes to exposure conditions like chloride attacks and carbonation attacks, because the pores are closed, you don't have such things happening often because the concrete is denser compared to the lower grade concrete, because those ones have a lot of pores that allows the ingress. But when it comes to the hydration processes where the heat can affect it, that is common with all. Even lower grades, I would say, will not have much cracks in terms of the heat generation, because the cement in such concretes are lesser. The impact they will have are different. They will not be the same as the higher grade concrete. So you have to make sure that the temperature is controlled. So there's a question. Please, when concrete travels from an appreciable longer distance from a batching plant to a transit mixer, should there be an increase in temperature, or there's a process to help regulate the temperature in the concrete? Okay, so that's what I said. The temperature of concrete, the temperature begins to rise when the hydration process starts. Now, most of these plants, concrete mixers, the mobile mixers you have there from the batching plants, they use what you call retarders or slam keepers. So what the retarders do is they delay the hydration process. So the concrete will be in the drum mixer, but the hydration process will not set in. So there was no heat generated. The moment the retarder, the effect of the retarder wears out, that's when it starts. But I understand your point, because once it's in the drum mixer and it's a metal and it's driving on a hot sand, definitely there's going to be some heat introduced to it. So by the time you pour the concrete, it could be hot because of that movement in the hot sand. So yes, we need to make sure that the curing process is on point. You put in measures that can control the temperature at the pouring stage, that can prevent some cracks from happening. That's what I can say about this. All right. I'll take two more, then we can end today's session. If there's any other question. There's also a form in the chat. If you can fill it for me.
Hello, sir.
Yes.
Yes,
Go
sir.
on, please.
So I wanted to know, what appropriate time is it due for casting of concrete? Is it daytime, morning, or evening?
Okay, so every time it's appropriate. You just have to put in the necessary measures. For instance, if you are going to cast in the hot sun, you have to make sure that you have your curing on point. If you need to introduce some kind of cold materials in the concrete, yes, you can do that. But most people choose the evenings, because the evenings you have the ambient temperature, which is okay for the concrete. But as I mentioned, when you are casting larger pours like thicker concrete, like 1.2 meters, 1.5 meters, then the evenings may also not be the best option, because the difference in the ambient temperature and the concrete itself, the temperature gradient is going to be high. yes, it's good that you can cast there because you see that, oh, the temperature is okay. But you also have to consider that the core temperature of the concrete will always be higher, much, much higher than the surface. In that sense, if you have a lot of water loss on the surface, there could be the setting of the surface of the concrete while the inner core is still not set. By the time the inner core is setting, it is pulling the surface because it's already dry because of the heat from it. So you need to understand how concrete behaves to be able to come up with the right way of casting it, irrespective of the time you are casting it. You can always put the necessary measures in place to make sure that these are properly taken care of.
So,
And
okay.
someone is
So
asking,
it
okay, go on.
doesn't depend on any at the temperature or the atmosphere or anything. All you have to do is to put in good proper measures in place to achieve the strength you want to achieve.
Exactly.
Okay.
Even though higher temperatures can accelerate defects, but as I mentioned, I mean, you can't, on a project which has a limited timeline, you can't say you are always going to pour in the night. You can pour in the day, but put in the necessary measures to be able to pour in the day. You can pour during the day, do proper curing. And you can see even all this road construction, which are concrete roads. You cannot say you're going to pour in the night because there are timelines. But and those areas have larger areas. They have to cast and cure it properly so that we don't have all these shrinkage cracks happening. All these cracks are happening. So, I mean, for me, cold weather helps, but it doesn't mean that that's the only time you can cast. You can cast concrete at any point in time, but just put in necessary measures to make sure that you don't have defects from happening. Somebody is asking, what are the best curing methods? You can use water is the universal curing material you mostly use. You mostly use water for curing. You can also use curing compounds. The curing compounds is when the concrete is in the plastic stage, transitioning to the solid state, you spray it on the surface, and that seals the pores of the concrete and prevents the moisture loss. So the water that we are trying to keep in the concrete surface to allow for hydration is going to be trapped within the concrete, and that allows for curing. So that can be done. So you can use water. You can also use jute. Sometimes people also even use a polythene to wrap it just to keep the moisture. All these are measures, but you need to understand how these things work. If it's a plastic, okay, how it works. If you are using water, how it works. But mostly on construction site, they will use water and curing compounds. These are the ones which are most effective on the project site. Okay, all right. If there's no any other question, I would like to thank you all for participating in today's session. I think going forward, there's a last question. Please, Samuel, you are the last one. We are not taking any question again after your question.
Oh,
Samuel, you can go on. Samuel,
hi, good evening.
hi, good evening.
I would like to ask, is there any other way of casting concrete with, let's say, probably a height of 5.7 meter, which is a column, without using the pump or a shooter?
5.7 meter height of a column.
Yeah.
You can do have you heard of tremi concrete before? How to pour tremi concrete?
Oh, exactly.
So you can either use if there's the reinforcement is not packed and you can put a pipe through it. You can use
Okay.
that. You can put a pipe and do probably a chute at the top of it so that you pour the concrete to it. The tremi concrete is simply like you are casting the concrete from the base. You are allowing the concrete to pour from the base and you come up. That's how you cast mostly. If you the pile, if you want to cast piles, you cast
Okay.
from the bottom. If you cast from the top, definitely there's going to be segregation.
Yeah.
Exactly. So you can put in some chutes, some pipes in the concrete. As you are casting, you are raising the pipe so that the concrete starts filling from the bottom.
Okay.
Yes,
Thank
that
you.
that can be done. Yeah. Okay. All right. Thank you very much for today, and